Alright, so today we will look at what are logarithms, and in short, I'll call it log. So let's say we have a base a to the power of x, or we call it index, all right, and that is equals to y. All right, this is what we call index form. So for example, it will be something like this that you're familiar with. 10 to the power of 2 is actually 100. Okay, and how do I convert it to log form? So actually this log form represents the power or the index of the base. All right. So specifically this log y base a is actually talking about this x, which is actually the index. So in short, actually, in converting that, right, we look at the index itself, which is x. We keep that there on the left hand side, and a goes over, the base a goes over as now the base of log. So now it becomes the base of the log function. Okay, and of course we have the y. So this is how we convert. Okay, so likewise, the same thing, we keep the power 2, all right, and then the base 10 goes over as the base of the log. So we have 2 equals to log 100 base 10. All right, so a short way, a simple way to verify this is this. So log base 10 is actually just LG 100. Okay, so here we can quickly verify this, and it is actually 2. So how then do we actually remove log function, right? So in here on the left, we have this log y base a equals to x. So this base of the log a is going to go over as the base of the index form, all right? And the x is going to move up. So what I mean is this, so keep the y here, and base a of the log function goes over to become the base a, and x moves up as the power or the index. So remember I said this earlier on, that this x actually, in fact, particularly this whole entire log function is actually the index of base a. And so the base a that I'm talking about is this. So the x itself here that is represented by log y of base a is actually the index of the base of the log a. Okay, so numerical way to look at it is this. So log of 25 base 5 is actually 2. Now later on you will learn something called a change of base law, and it allows you to very easily verify it, which I will not go into detail. So basically this 2, the way to understand this is that this 2 is actually the index of the base 5 here. All right. So therefore, if I were to remove this log function, basically 25 is equal to base 5 raised to power 2. So in a very casual sense, I can simply just say that, this 5 goes over as the base, and then 2 moves up to be the power. Something like that would help you to easily remember. But conceptually speaking, this 2 actually represents the index of base 5, which this base 5 can be found here. So therefore, 25 equals to 5 to the power of 2. So for the first 3 laws of logarithm, the first one we have is actually the power law. And what this does and what this allows us to do is to actually bring down the power. All right. So for example, if I have log x to the power r base a, this law allows me to bring down the power r. So we have r times log x base a. So a simple example here would be, for example, if I have log 3 to the power x base 2, and this law allows me to bring down the power x then times log 3 base 2. So in the second law, we have product law, which gives us a way to combine two terms with log of the same base together into one single term with log of that base, right? So for example, here what we have is log x base a plus log y base a. Since both of them are of the same base, and this is important, right? Then we can combine them into one single log base a term whereby we have log x times y base a. So a simple example to see this is actually I'll be using log base 10. So if I have log 4 base 10 plus log 25 base 10, which I write as lg4 plus lg25, then applying this law, what we have is actually log of 4 times 25 base 10. All right. So we can separately see the left hand side, what is the answer and what is the answer for right hand side as well, just to numerically check on the validity of that. So I have log 4 plus log 25, and that's going to give me 2 on the left hand side. Then now we'll check the right hand side, which is log 4 times 25, and that gives me 2 as well. So since the left hand side and the right hand side are equal, this is verified to be true. So next, in maths, a lot of time when we have something is a plus, then there will be something that is a minus. If there's something that is a times, then there will be something that is a divide. So what happens if I have log x base a minus log y base a? And again, the same important thing is that both of them are of the same base. All right. So product law and quotient law, which is law 3, only works if the two terms that we are combining is of the same base. All right. So for quotient law, the right hand side of the result would be log of x over y base a. All right. So you can actually just do a quick comparison between product law and quotient law and see that the plus becomes a minus and then the times becomes a divide, and that gives us an easy way to remember, and you can pretty much just remember product law and see an extension for quotient law. So here I will use another simple example again using log base 10. So I have log 10 base 10 minus log 5 base 10, and applying this law I will have log of 10 over 5 base 10. All right. So if I were to numerically check the left hand side and the right hand side of that simple example, then I'll have log 10 minus log 5, and that's going to give me that whole long string of numbers, but not going to worry about that. Then I key in the right hand side separately, 10 over 5. All right, and you can see on the calculator here that both these two gives the same numerical result. So the left hand side and right hand side are equal to each other, so that verifies the validity of that working, and so we have applied quotient law correctly. The last law that I'll be talking about, which is something of a little favor of mine, is actually the change of base law, right? So why do I like this so much? Because a lot of times where we look at log terms and it's of a base that is not 10 and it's not natural log base e, right? It's difficult to figure out what is the value. For example, if we have log 3 base 2, and then I'll be wondering what is the value, all right, of that. So change of base law allows me a way to numerically compute what that value is. So that is one powerful thing about it. And the other thing is that in the other laws that we've presented earlier on, those laws are really for situations whereby the base are all the same. So as you work on logarithm problems, the very crucial question you'll be asking yourself is, are the log terms of the same base or not? If they are of the same base, then you pretty much can apply either product law or quotient law. But if some of the terms are of a different base, then that gives you hints that you could possibly need to consider doing, or very likely to have to do, the change of base law. So here you can see that if I have log b base a, right, and the formula gives log b base c over log a base c. So now what we have done is actually to convert the base a into a different base c that we choose. And exactly what base we choose depends on the situation. All right. But here, how do we apply it then? So a simple way for me to remember this is log b. This b goes into the numerator, and base a will go to the denominator. All right. So this is an easy way for me to remember. So as I mentioned earlier on, I want to see what is the value of log 3 base 2. So I'm going to convert this to log base 10. All right. And so I'm going to put LG, and then 3 goes into the log in the numerator, and then 2 goes into the one that is in the denominator. All right. So once this is done, we can actually key this into the calculator. Log 3 over log 2. All right. So the calculator tells us what the value of log 3 base 2 is. Then I have a question. If I change to a different base, does that mean that the answer is different? Logically speaking, no, because if you have log 3 base 2 and based on the change of base law, I change to base 10, right? It gives me a certain value of 1.58496 and so on. Even if I change to a different base, that shouldn't give me a different value, because then that will be altering the value behind log 3 base 2. So I'm going to change it to natural log, which is ln, or log base e, ln 3 over ln 2. All right. So is that going to give me a different value? Let's see. Ln 3 right over ln 2, and now you can see that both of them gives you the same answer, and this is important. So we see that no matter what base we change to, the change of base law still outputs a result that will give the same value as the original. So don't worry, you can change to base e or base 10 or whichever other base. It should not alter the original value, and that's important, right? And as for when you change to base 10, when you change to base E, and when you change to maybe even base 2, it is situational, right? And these are things that you will gain insight only when you start trying some of the question. All right. So that's all for this part on the law of logarithms. So here I have two simple examples where we are required to simplify the following logarithmic expressions. Right. So for the first one, I have log 3 base 6 plus log 2 base 6, and then how I can simplify that is that, first of all, you need to check whether the base are the same. So in this case, both of them are base 6. So therefore, that means I can apply the product law and combine them into one single log base 6, and 3 times 2, which is actually just 6. Log 6 of base 6 is going to give me a 1. All right. And that is for the first example. For the second example, I have 2 times of log 7 base 6 minus log 5 base 6 and plus log 10 base 6. So again, first thing you want to look at is, do they have the same base? If they don't have the same base, then I will have to apply change of base law. But turns out they are all of the same base. So therefore, here I would just try to combine them. But before I do that, I notice that here I also have another problem, which is this 2 here. So I apply the power law. So on one hand, we say that the power can be brought down and be put outside the log, but we also can, in reverse direction, bring it up. So here, what I'll do is bring it up and becomes log 7 to the power of 2 base 6. Next, I will then be able to combine and here I can first combine the first two terms, or you can reach the last step without going step by step, and that's fine as well. So therefore, we will have log base 6 7 to the power of 2 over 5, right? And then plus log of 10 base 6, right? And then going on from here is that I can again combine this, all right? Log of 7 to the power of 2 times 10 over 5 base 6. And this simply will just give us 98 inside. So this is actually, sorry, I just have to put it here, log of 98 base 6. So in the last example here, if I were to simplify log 10 base 6 times log 3 base 2 times log 6 base 3 times log 4 base 10, which I will just call it as log 4, then I first need to notice that all of them have different bases, right? And then for the last one is actually base 10. So that gives me a clue that I probably will need to use the change of base law and then converting them all to the same base. So then which base? Since I have a log base 10, why not I try to convert all of them into base 10? So I have here log 10 over log 6 times log 3 over log 2 times log 6 over log 3 times log 4 finally. Okay, so I'll try to simplify some of them first. First of all, log 10 base 10 is going to give me a 1. And try to see possibilities to what we love to say cancel, but actually it's just dividing the same number top and bottom. So I have here log 6 over log 6. So dividing log 6 in the numerator and the denominator of these two fractions, and I'm gonna be able to cancel off the log 6 like that. So of course I also have log 3 and the log 3. All right, so then what am I left with is basically by combining all of them, actually I'll just have 1 times of log 4 over log 2. All right, and then the next thing is then how do I simplify this? Because the problem is that I can't just take log 4 divided by log 2. There's no rule for that, and don't confuse it with quotient law as well. So what I do here next is actually log 4 is actually log 2 to the power of 2, right? And over log 2. And then finally that is 2 log 2 over log 2. And this means that it is actually just 2. Okay, and that's it. So this is how we apply the change of base law.